Yes, question.
It seems like maybe one way to map it is changing side of u prime. Can you just solve for the antiderivative, then put it in terms of x? So we've got the antiderivative 118u to the 6. Can you then put that in terms of x? And
so if you want to do things with where you're worrying about the sign change, the right strategy is what you suggested works, and in fact, I'm going to do an example right now on this subject. But the right strategy is to break it up into pieces where u prime has one sign or the other. Okay? Let me show you an example. Okay, but where things go wrong, and I'll tell you how to handle it roughly. So here's our warning. Suppose you're integrating from minus 1 to 1 x squared dx. Here's an example. And you had the temptation to plug in u is equal to x squared. Now, of course, we know how to integrate this, but let's just pretend we were stubborn and wanted to use substitution. Then we have du is equal to 2x dx. All right? And now, if I try to make the correspondence, notice that the limits are u1 is negative 1 squared. That's the bottom limit. And u2 is the upper limit. That's 1 squared. That's also equal to 1. Both limits are 1. So this is going from 1 to 1. And no matter what it is, we know it's going to be 0. But we know this is not 0. This is the integral of a positive quantity. And it's not the area under a curve. It's going to be a positive area. So this is a positive quantity. It can't be 0. If you actually plug it in, it looks equally strange. You put in here this u, and then so that would be for the u squared. And then to plug in for dx, you would write dx is equal to 1 over 2x du. And then you might write that as this. All right? And so what I should put in here is this quantity here, which is a perfectly OK integral, and it has a value. I mean, it's what it is. It's 0. So, of course, this is not true. And the reason is that u was equal to x squared, and u prime of x was equal to 2x, which was positive for x positive and negative for x negative. And this was the sign change which causes us trouble. If we break it up into its two halves, then it'll be OK, and you'll be able to use this. Now, there was a mistake, and this was essentially what you were saying. That is, it's possible to see this happening as you're doing it if you're very careful. There's a mistake in this process, and the mistake is in the transition. This is a mistake here. Maybe I haven't used any red yet today, so I get to use some red here. Oh boy! All right, this is not true here. This step here. So why isn't it true? It's not true for the standard reason, which is that really x is equal to plus or minus square root of u. And if you stick to one side or the other, you'll have a coherent formula for it. One of them will be the plus and one of them will be the minus, and it will work out when you separate it into its pieces. So you could do that, but this is a can of worms. So I avoid this and just do it in a place where the inverse is well defined and where the function either moves steadily up or steadily down.